AI isn't just for software, as companies like Flux AI are leveraging generative AI to act as a designer to bring your ideas into the real world. They enable a user to design electronics, creating the schematics needed for a contract manufacturer to produce it. Flux AI is also a community of users for support and ideas. Will AI enable on demand manufacturing of just about anything we can dream up? That's the question on this episode of Utilizing AI with Olivier Blanchard and Matthias Wagner. Welcome to Utilizing AI, the podcast focused on practical applications of artificial intelligence from the Futurum Group. Every Wednesday, we explore news and use cases of the way in which AI is transforming enterprise IT and the industries it serves. I'm your host, Stephen Foskett, president of the Tech Field Day business unit here at the Futurum Group. And today we're talking about bringing AI into the real world. But before we dive into this discussion, let's meet who's on the panel today.
Hi, I'm Olivier Blanchard. I'm a research director at the Futurum Group, and my primary focus is intelligent devices. So anything that has AI embedded in it, from rings and other wearables to PCs to the IoT to robotics to cars, is the stuff that I focus on.
Hi, I'm Matthias Wagner. I'm the founder CEO at Flux. At Flux, we aim to take the heart out of hardware, and we're building the first AI hardware engineer to help go from a prompt to any physical product you can imagine.
Excellent. And again, I'm Stephen Foskett, the organizer of Tech Field Day and the host of Utilizing AI. So I am an IoT enthusiast and all-around nerd, as you can see from the background if you're watching the video. And of course, it's pretty exciting to think that somebody like me, without hardware design experience, could develop a specialized IoT device just by talking, yelling at my computer. But I think, Matthias, that's pretty much what Flux is doing, right? You want to tell me a little bit more about what it is?
Yeah, totally. I think you're spot on, right? You can come to Flux, and just like if you think ChatGPT, you can enter a prompt, you get a poem or some marketing copy out of that. With Flux, right, you can enter a description of a device you want to design and manufacture, and then Flux will go and design that for you. Right, we'll source out the components, figure out the architecture, ask follow-up questions to nail down the details you haven't thought of, and then go ahead and design that for you, and get that manufacturing ready. And that can be really pretty much anything. I'd say, there's simple devices, think controller for farming irrigation systems or so, to the kind of controller boards that sit in vending machines, all the way to the kind of electronics that go into a satellite and go to space, right? So that's kind of the range of applications we've seen so far.
Yeah. So one of the questions I have for you, actually, Matthias, is what level of proficiency in PCB design is this really for? Can someone, say a tech savvy, remotely tech savvy farmer, for instance, who wants to build their own drones or their own equipment or their own sort of sensor technology to do very specific things on their farm or in their agricultural facility, could they just come to this and use Flux to go from zero to complete design? Or do they need to have some semblance of training already or experience in that field?
Yeah, great question. Well, I think you're spot on there with the user segments, right? So that's exactly the kind of users that come to us today. We do have indeed farmers who are building their own farm automation equipment. And so I'd say anyone with a somewhat technical background can grok this today. Of course, what we're working towards too, right, is these, if you think about how easy it's become for 12-year-old kids to build iPhone apps, we want to enable them to build their own iPhones down the road, or an iPhone equivalent device, right? And that's what we're aiming for. But today, yeah, it's mostly technical crowd. These are not users who have necessarily designed a PCB before, but they have maybe a mechanical engineering background, or industrial design background, right? Or software engineering background, right? And then, we make this as easy as we can here for them to design a board. And look, in some simple cases, you can really go from a single prompt to the fully finished thing. And in other cases, take a little bit back and forth, on being more specific about what you want, and steering it in that direction. So I think it's not unlike your typical, ChatGPT session, but sometimes from the first prompt you put in, you get exactly what you wanted. And other times you have to nudge it a little bit into the right direction.
Okay, that's pretty good. So what type of equipment do you need for this? Is this just any laptop? Do you have to have minimum specs to run this? And I also assume that just from looking at the website, right? There's certain types of files, so you have to be able to run some kind of design software on this, like CAD or something like that, or is it all cloud based and included in Flux?
It's batteries included, right?
It's
So
battery included.
Flux runs in the browser. You need nothing else. It's like I always say you can go here from like the idea to the fully finished product, all within Flux, right? So no, you don't need anything else. In terms of specs, I mean, look, I think like any kind of machine made in the last 5 years or so will do fine. An older one probably too. I think it depends a little bit on the size of project you have. Like a larger, more complex project is going to take more memory, and then sure, maybe you want like a more high-end machine. But I think any average machine made in the last 5 to 6 years will do fine.
Cool. Okay, so following on this line, we'll switch in a little bit, but I'm interested because I might actually be interested in using this, and I don't have necessarily the practical skills required to do this, even though I have the theoretical skills as an analyst. But I saw on your website that there's a human support element to this, where users of Flux can call on an active builder community, I think is how you phrased it,
Mhm.
and also engineers who might be on call. How does that work? Is that sort of like a free floating community that can just use Flux as sort of a meeting point, or do you have staff that helps customers? What's the model there?
Yeah, great question. I mean, to start with, right, Flux is a platform that's much designed like think GitHub, right? GitHub is this like pillar in software engineering, right? For engineers to work together, to collaborate together, to learn from each other, and to use each other's stuff, right? All these like breads and butter kind of things you need to make software, whether it's like an encryption library, a server library, whatever. You can find those in GitHub and use those and remix them and all that kind of stuff. And so we've built the equivalent of that for electronics, right? Like if you think about electronics, you need the digital representation of a semiconductor or so, right? And somebody needs to put that in there. And so that's either comes from the semiconductor companies themselves that are represented on Flux, right? Or that comes from users who do that, or semiconductor distributors, right? So there's a big community aspect to that to create these like nuts and bolts that you need to build your stuff there. So that's on like the first layer. And then, of course, yeah, we have like a big Slack community where people post jobs, where people look for jobs, if they have questions, or they brainstorm ideas. And, I think the idea is that everything is better if you do it with others. And that's what providing there. And so there's other users there, there's power users there, and there's, of course, also like our team members are there. I'm out there, and it goes all the way from like, reporting a bug and getting that fixed, to explaining to how something works, to like learning what to build next for us, right? What's missing here? Where are the gaps? Where do people get stuck? And so, yeah, but I think, if you zoom out here, when we started a company, it was clear that what we were doing was really big and ambitious, and it was going to take a long time, and it wasn't going to work if we wouldn't like work directly with the users from day one, right? And so I remember like we started a company 6 years ago, and we shipped the first, I don't even want to call it a beta. The first thing we shipped like 3 months in, and it was embarrassing to demo that to users. But we learned from that, right? And we moved the whole thing into the right direction, and kept focus on that. And so that's it's like that spirit here lives on, right? To be close to users and get feedback and do better.
So once you've made the design in Flux AI, AI can't manufacture things. So I assume that you produce a production ready schematic that can be then sent on to a contract manufacturer, of which there are many now who would be happy to manufacture, small or even large volumes of these things. Can you talk a little bit about how it goes from ideas to designs to actual physical product? I mean, you held something up in your hand just a minute ago. I'm assuming you didn't solder that together. Who did?
I try to avoid soldering these things these days because it's tedious. because it's so tiny. You can't even see that here, but there's like tiny, tiny components here. So no, what's the process look like? Yeah. So today how this works is like, yeah, when you're done in Flux, we give you the manufacturing files. These are typically called Gerber files. There's some other formats, but and then any manufacturer in the world, of which there's 10,000, right, can take these files and make this for you. What's interesting in PCB boards is like that making PCB boards has been automated for a very long time, right? The whole form factor here exists because it's automatable. That's the whole innovation here, right? And so in that sense, can AI make this? I mean, it kind of does, right? A robot will actually assemble this, right? And what we are essentially providing you is the files to program these robots on the assembly line to do this for you.
It's funny. I actually, to that point, I actually have the name tag on the front of my office at. I'm at home, but at the office here is a PCB that was created as a one-off, and it just spells out my name in the traces. And so you're absolutely right. I've definitely seen this in action, and of course, I've got friends as well who have had contract manufacturers. But of course, what I hear from folks who've been involved in this is that there's often a bit of back and forth and fine tuning, all that. Is Flux helping with that whole process as well?
Yeah, it's a great question. So yeah, look, ideally there isn't back and forth. Your design is straightforward. They just make it. 8 days later, you have it on your doorstep, right, ready to go. But you're right. In some cases, the manufacturer has some questions or feedback. Today, what you can just do, you can just copy, when they email you, you just copy paste that into Flux, and the Flux will fix that for you, right? But of course, what we're working towards too is like to integrating that too, right? Because that feedback is, of course, an important step of the learning loop for these agents, right? To learn what mistakes they made or what caused friction in manufacturing and to not do that again in the future, right? And I think that's one of these big compounding effect things here, or network effects you have in AI, right? Humans, of course, learn too, but it's a much more lossy process, right? Whereas like these AI models, when they learn, they tend to not forget that. And so it's very effective. And so you reach quickly here like a high saturation of like knowledge that prevents them from making mistakes in the future. At least for like that category of problems you work on.
Right. So my next question, if I can get in there real quick, is I just got back from CES in January, and surprisingly enough, the big theme at CES wasn't necessarily AI or AI PC or AI devices. It was robotics. Even though I think we're still very, very early in the game, every single vendor that I talked to, even the keynotes from the big semiconductor companies, from Qualcomm, Intel, AMD, NVIDIA, ARM, NXP, Texas Instruments, everybody was about robotics, whether it's robotic arms or delivery robots. Obviously, humanoid robots are always the flashy thing that's shown on stage. But it feels like we're at an inflection point with robotics in general, all form factors. And I look at your company, I look at what the service that you're providing for designers and for small businesses, large businesses, and the power that you're sort of democratizing in terms of designing uh, uh, even FPGAs. And I was wondering if you could talk a little bit about where you think you fit into, I think this transition into sort of mainstream robotics, and how your company, how Flux specifically, with this prompt-based model, can help accelerate that, scale that, and make it more available for a lot more companies, whether they're startups or established companies that just want to build their own robotics departments.
Yeah, good question. Where to start? I think with robotics, but yeah, you're totally right. It's an exciting time because we have like for the first time now these like reasoning engines, right? And for robotics, like the hardware we've had for a while. If you look at what Boston Dynamics been putting out for the last decade, right? It's incredible stuff. But we didn't have these reasoning engines, right? And so now we have those, and so it's like a new wave of innovation now in robotics. And at the same time, right, you've seen it with all the demos you see. Yes, these robots can reason now, but they reason very slowly, right? It's like
Yeah.
watching like a tortoise, eat a leaf of salad or so. And I think that will get figured out, right? I think we're very early, and we're probably still a couple of years out from seeing like a truly humanoid, latency kind of capability robot. But I think it's going to happen. I think in the meantime, there's of course a huge opportunity for these like domain-specific robots. Like think about, trying to think of the company's name, but there's like a company that make like robot vacuums, but with AI now, right? And that's a huge leap forward towards what we have with this like Roomba generation of vacuums. They're kind of like, they work, but they're kind of dumb, right? They'll eat a USB cable, every time. And so I think there's like, you're going to see a lot here now, starting already now. And I think Flux is kind of like in the same category, right? We're like very domain specific. It's an AI model, an AI agent, or a robot, if you want to call it that, to make PCB boards, right? And it doesn't make that by being a humanoid robot that you tell to and it sits there and solders this for you all day, right? It does that by being very special on the design and then being able to utilize the existing manufacturing capacity of the world economy, right? To then turn these designs into real products, right? And I think that in this domain, I think it will probably a couple more decades until you have humanoid robots who could replace that capability. But it's in the end, Flux is also just a giant robot.
Yeah. No, it's cool. Like I feel like you're the right company at the right time, especially with how much easier you make it. Just before Stephen asks you his next question, I'm wondering if how well you scale. Let's say that everybody discovers Flux, right? Worst problems to have. And everybody wants to start using it and building their own boards and developing their own robots and their own systems, or improving on existing ones. Can you scale well enough to meet that kind of demand, or are you currently structured where it might turn into a first come first served kind of service?
Yeah, great question. No, I think the way we see this is this, right? There's a market of tens of millions of users in the world ready to adopt Flux, and that's like mostly people who've like worked in technical fields before, whether again they've before just used mechanical CAD tools, right, and then just bought the electronics from an OEM or contracted that out. I think that market is up for grabs here now for a company like ours, right? But if you go all the way here, right, then look, if I can type in a prompt and I can get any product manufacturer, I can type in any idea and get this back within like 10 days, manufactured, ready to go. And we do this for electronics today, but why would we not also deliver the enclosure for this? Right, the enclosure for this is pretty simple. We know where the plugs are, where the heatsink has to go. We can make the enclosure for you. And most enclosures aren't like, a piece of jewelry like your iPhone is. Most enclosures are gray PVC boxes, right? Especially in industrial applications. So that's not so difficult to do. But if you can do that, right, then why would you still go spend 2 hours on Amazon looking for the product you were looking for if you could just describe it and it got made for you?
Yeah.
Right?
Yeah.
And so I think on that level, right, then there's a market of billions of users, right? And that's a long road, but that's the road we're on.
Yeah.
No, that makes a lot of sense.
What about that? So let's take that to the next level. So you're talking about designing PCBs here, but what about everything else? I mean, it's got to have an enclosure. What about batteries? What about you're building your giant robot? You've got motors and wiring and joints and whatever else. What about screens? What about everything else? Is that all part of the Flux world as well, or is that something that's handled differently?
Yeah, it's a great question. So today we're hyper-focused just on everything that goes to make this board, right? And look, and if the display is mounted on this board, that'll work, right? And we do this simply because, like I said earlier, right, this is a form factor that was designed to be automated. It's meant to be fully automated for 100 years. And then we're finally here now where we can actually fully automate this, right? And so that's kind of like the beachhead here, that we've built out for ourselves now. And we're doubling down on that for the coming months. But then, right, I think from here we go to enclosures. From there, we're going to go to like, something that has a PCB board, an enclosure, and maybe motors or a display or the batteries or bunch of sensors that are not on the board themselves, right? And yeah, from there we're going to go to full robots or smart toasters or you name your category, right? Because there is like there's huge infrastructure in the world to build these things if you can deliver them the design files, right? Like the bottleneck isn't in the manufacturing capability. There's thousands of manufacturers just in China, right, who would love more business and who don't care whether they make 5 units for you, 1 unit, or 5 million units, right? They're just looking for more business. And so that's kind of like here the need, that we're serving, right? And in the short term.
Yeah. I have a question about software real quick. So, and the answer might be very, very short. But essentially right now, obviously this is really good, but it's also fairly new. I'm wondering if you like where the limitations of your software, and especially the sort of like prompt based, design generation, that you have the AI working in the background. What are some of the limitations that you're working on improving for 2026, where
Yeah.
you're not as good as you'd like to be yet in some way? And if the answer is no, we're great, we can, everything is perfect, that's a fine answer too. But I expect that you probably have some things that you want to improve on. I'm just wondering what those are.
Yeah, great question. No, everything's perfect. I sleep wonderfully at night, every night, No, it's a bucket with a lot of holes. That's the reality of it, right? That's the fun part. Yeah, where is it falling short? I think the big issues here that we're working on is just recall, right? So look, it's not good enough if the model gets it right 8 out of 10 times, right? Especially along a chain of like thousands of decisions that need to be made, right? If you along every step only get it 8 out of 10 times right, then at the end you got it all wrong, right? And so that's something we're working on. And then the other thing is like speed, like doing that faster, right? I mean, yes, you could argue look, it's a miracle that the model can do something in an hour that would have taken an expert weeks, right? But if you really want to wield this like a guitar, which is like, think about a guitar, right? It's an incredible tool. It's like so intuitive and responsive, right? And playful, and you can discover, right? And it's like the feedback loop is really fast. We think that that's kind of like what really amplifies, human innovation and creativity, like fast feedback loops, right? Try something, get a response, try something new. And I think that's what we're trying to get to here with Flux too, right? To be really like a sparring partner, and where you can really go quick and forth and play with idea and iterate, right? Because, we've all like made things, whether we've written something or built something. It's all about getting into like an effective loop here, of like making something, getting feedback, whether it's good or not, changing a little bit, trying it again, right? And that's what we're trying to get to. And then, the third side, maybe much more boring, is to just support much more manufacturing processes, right? If you think about PCB boards, like if you want to make, even if you want to make an actual iPhone, right? An actual iPhone is like 1,400 components, 12 layers. It's like a very high density design. And you need to support like a bunch of manufacturing processes to make a board like that. And we don't have them fully covered yet, or like at the level where you could actually effortlessly make something like an iPhone, right? And so that's what we're working on.
Right. No, those are
And
good
that's
answers.
that's what keeps me up at night.
Yeah. Thanks for being candid about that, because you could have just basically said, no, everything's good. A question about that. So in a past life, I was a product manager, and so I helped develop new products and upgrade old ones. And I remember, I think it was an IDEO tenant, IDEO, the design firm, right, from the 90s. That was fail as fast as you can, or something like fail fast, succeed faster. And this seems to me, you talked about something that would have taken a designer weeks, just a mere hours with this, and that's how you're shrinking that time envelope. I wasn't thinking necessarily, when I'm listening to you talk about this, about the finished product. I'm thinking about, as this former product manager, the prototyping process of all these different iterations. Like, I have an idea, I want to build this. I want to create a working prototype as quickly as I can so I can test it, and then see if that's really what I need, or if I want to add some features, make some changes, and then take what I learned, what works, what doesn't, iterate until after 2 or 3 different iterations, or maybe 15, I finally arrive at a manufacturer tested prototype that works, and that I can fairly quickly turn into a production ready product. So to me, in all of this, one thing that we haven't talked about really is this process of either failing quickly or learning quickly, and getting there faster through these prototype iterations. Do you think that is still an old school way of doing this? Do you think that your tool helps get to that finished product with fewer iterations, or is it just, faster iterations to get there? Not less necessarily, but just getting there faster.
It's a great question. I think if you look at like AI coding tools, which I would say is probably like the bleeding edge of AI right now, the process to make software has drastically changed in the last 12 months. Right? It has changed more than it changed in the last 40 years or the last 12 months. Like 12 months ago, if you wanted to build a feature in like some piece of software, right, you would probably start with like a conversation, a whiteboard exercise. Your designer would throw some mockups together. Then you maybe do some user testing with that. Eventually, you would get somebody to implement that, test that. Right? It's like a lot of steps in the process. And if you look at like software teams like us, like work now is, we skip all that. Right? Somebody has an idea at 2 a.m. in the morning, right? They type the idea into one of these coding agents, and the coding agent will just build the thing into our actual product, right? And on Monday morning, they just show off that working thing in the product that's like ready to be shipped or really close to be ready to be shipped, right? And I think that's kind of what we're going to see happening here in hardware too. It's what we're working towards too, right? Is to like remove all these in-between steps.
Yeah.
Right?
Yeah.
And make it much more responsive and intuitive, right? Again, like going back to this guitar example, right? It's like a guitar. If I like pulled a string and then had to wait 5 days to get like the sound back, that would suck, Like a guitar would not be as popular as it is today if that was the case, right? It is so popular and, adopted and fun because it's so immediate, right? And this immediacy, I think we're seeing that in software happening now, right? And we're going to see that in hardware too now over the next 12 months.
Yeah, no, this could become addictive for
it's
tinkers,
fun,
right?
Look, it's fun because you can try so many things, right? Before, right, in this like linear sequential world we were in, I had to have an idea, I had to like kind of spec it out, try it out. I could only do one thing at a time, right? That's another thing with these AI agents. I can now try 20 ideas at the same time. As these ideas come, I just drop the prompt, and then an hour later, I check back in where it ended. And then look, maybe it went nowhere. That's fine. No, I don't care. It's just a random idea. Maybe it's actually amazing, but then let's double down on that, right? And that's like the power you get here now. And I think in hardware, that's going to be amazing. Because you know how expensive it is to run one process? Like, you can't try 20 different things, right? Because there isn't enough time and money in the world, right, to do that. Even like at large companies with lots of resources, like you think of Apple here or Meta making hardware, sure, they maybe have like 4 or 5 different teams working on different versions of the same product or idea, right? With AI, they could be working on like hundreds to thousands of different approaches to the same idea, and then pick the winners or mix and merge the winners, right? And at mind-boggling speed too. And so that's kind of like the elasticity and immediacy we're working on.
Yeah, no, this is very Tony Stark, in a little bit, right? Just kind of.
Oh, for sure. No, this is exactly. I have a screenshot of that in our pitch deck for investors, right? No, you're spot on,
Yeah,
right?
really?
I think this is exactly like the kind of future that's going to be real within a year.
Yeah, no, it's great.
And it's going to be available to everybody, right? That's another thing. This is going to be like Tony, like in the Marvel universe, only Tony Stark has this, and that's why he's the Iron Man and has all these things. But like in the future we're building, everybody's going to have access to this.
Right. Which means also that you're sort of flattening a lot of the moats that keep some companies with all this expertise and all this investment sort of in the lead. You're making it much more accessible to startups or individuals or even universities who want to really innovate in that space.
People always ask me who we're competing with, and they think of the legacy tools here. And I tell them like, no, the legacy tools are not what you're competing with. That's actually a really small market, the existing PCB design software market, right? Who we're competing with is the OEMs. right? I have like my favorite example here is like we have a customer, they make vending machines like for snacks and beverages. And they used to, before they started using Flux, for a single vending machine, it took like 4 or 5 individual PCB boards that they had to like buy from a distributor, who bought it from a distributor, who bought it from a distributor, who bought it from an OEM somewhere, right? You had to integrate those into a single machine on the assembly line, configure this, wire it up, right? Then in the field, one of these machines breaks down. You've got to bring replacements for every single board, figure out which one's broken, replace that, right? It's workable, but it's cumbersome. Now, fast forward that to them using Flux now, right? They have a single custom board made with Flux that does exactly what they want, no more, no less, right? The board costs them pennies on the dollar because they're just paying materials now. There's no distributors or middlemen that get a cut, right? On the assembly line, you put one board into the machine, cable in, it's working. The machine stops working in the field, there's one board to replace, right? So the total cost of ownership suddenly is like 1/100th of what it was before, right? Plus, you can make it exactly what you want. You're not dependent on somebody else to build the thing you want. You can make it that, right? And that's the power, that's the opportunity here.
Yeah, no, it is. I couldn't have said it better myself. So I think this is all the time that we have. So I really appreciate it, Matthias. This has been really interesting. And now I'm not just interested in Flux as an analyst. I'm actually interested in Flux as a potential practitioner. Like I feel like I might actually be able to start dipping my toe in this PCB design space. Which I think is the point of this. Like everything that we just talked about, I mean, throughout this episode, obviously, this podcast, but also really in the last 5 minutes has been sort of encapsulated this opportunity of this intersection between AI, browser-based AI, that can basically allow you to describe what you want to build, and as a companion, as an expert, it helps you build it and get from basically idea to manufacturing. And I really want to thank you for your time today and explaining this, and also for your vision in building this, because this is the kind of application of AI in the real world. That's a lot more real than a lot of the other AI applications that we've heard about. And also, it's ready now. It's not something that we have to wait for 6 months or 2 years or 3 years. It's available now, right now. So I'll thank you again. I'm going to turn it to Stephen.
Thanks.
And I hope that we can continue this conversation soon.
Yeah. On that note, before we go, Matthias, where can people continue the conversation with you? Where can they learn more about Flux AI? And will we be seeing you in the physical world anytime in the coming months?
Yeah, great question. So look, you can find us at flux.ai. That's a good starting point. If you want to start building, start, exploring what this new world looks like, yeah, come there, sign up. Where you can find me, look, you can find me on Twitter or LinkedIn, just DM me if you want to get in contact with me. I'm out there. In terms of physical world, great timing. We've been remote for the last 6 years. We're moving into an office, right? So we have an office in San Francisco in downtown on 2nd Street. So, we're aiming here, like as we're moving in, to also host a bunch of events here, and turn this into like kind of like a maker space, if you will, of the new age, right? Where we together here figure out how to build this, and I think that's the big thing here. Look, we're extremely early in all this. This is day one, right? And if you're excited here about exploring this, definitely come and try out our product. But also, like, if you want to get involved here, get involved with the community, look, we're hiring. Any role you can imagine, we're hiring for it, right? If you also want to be part here and help us build this, there's a lot of stuff to be figured out. We're really excited about it, and we think now's the time. So let's do it.
Excellent. Well, hopefully we can see you. We're out in California for Tech Field Day fairly often in the Bay Area, so maybe we'll see you at one of our future Tech Field Day events.
That would be awesome.
Olivier, what are you working on these days? What can we look forward to hearing from you?
What am I not working on? Robots, apparently, but any kind of physical AI. So we have reports coming out fairly regularly, whether it's a market forecast for devices, PCs, etc., or semi-annual IT decision maker surveys that look at how the enterprise is looking at investing in AI and AI devices. I attend pretty much all the conferences, or at least all the major ones. So you're bound to see me at anything that has AI and devices sort of like converging. Obviously, we just did CES. I'll probably be at Mobile World Congress in Barcelona, and then many more beyond that. Where you can find me is on X, formerly Twitter. Just look for Olivier Blanchard. You'll find me fairly easily. I'm on LinkedIn. And obviously, if all else fails, you can Google me or look for me at the futurumgroup.com website, where I publish semi-daily articles and commentary on tech.
Excellent. Thanks a lot. And as for me, you'll find me as S. Foskett on most social media. And of course, as I mentioned, I am a nerd, and so you'll find me dabbling with projects like Home Assistant and ESP Home, which I'm sure Matthias is familiar with as well. Um, and thank you, everyone, for listening to the Utilizing AI podcast. If you enjoyed this discussion, please do subscribe on YouTube or your favorite podcast application, and consider giving us a rating and a review. This podcast is brought to you by the analysts and experts at the Futurum Group, where insights meet AI. For show notes and more episodes, head over to techstrong.ai, the Utilizing AI YouTube channel, or the TechStrong TV app. Thanks for listening, and we will see you next Wednesday.